Okay, here we are in Ex3C. I was asked question 10 here. I suspect, I didn't read perhaps carefully the email that I was sent. I think it was here or certainly here. I would think that the student ran into trouble. But I'll do the whole question. So you're asked to imagine that omega happens to be the cis of 2 pi on 9. Being the solution to, here we are. And so A, it's saying, well, does W to the K, does omega to the K solve that equation? So omega to the K to the power of 9 is obviously omega to the 9K, and rather, probably the smarter way to write that would be to write that as omega to the 9th, all to the power of K. Omega is the cis of 2 pi on 9, which when you raise that to the 9th, you're going to get the cis of 2 pi, which you're going to get as 1, which equals the right-hand side you're after. So clearly it does solve that. It's just saying, therefore, really what that's saying is the cis of 2 pi on 9 solves this equation, but so does the cis of 4 pi on 9, 6 pi on 9, 8 pi on 9. Any integer multiple of 2 pi on 9, when you take the cis of it, will be a solution to that equation. You can't get far in this chapter without sort of understanding that already, right? So that's not part A. There is a sort of obvious show of a thing that we can sort of clearly understand. Part B, I think the student who asked me this already recognized that if omega to the 9th equals 1, then omega to the 9th minus 1 equals 0, and they have performed the classic factorization of those powers, which I'm going to write in descending order. 8, 7, 6, 5, 4, omega to the 4th, omega cubed, omega squared, omega and 1 equals 0. So therefore either, maybe so let's like NB omega equals cis 2 pi on 9, which is not 1. Therefore, omega to the 8th plus omega to the 7th plus omega to the 6th plus omega to the 5th plus omega to the 4th plus omega cubed plus omega squared plus omega plus 1 equals 0. And do I really need to write the last line? I guess I do. Omega plus omega squared plus omega cubed plus omega to the 4th plus omega to the 5th plus omega to the 6th plus omega to the 7th plus omega to the 8th equals minus 1 as required. Hence show the cost, the sum of costs or something. So I don't know what, pardon me, that's just a message about my dog running away. Part C, it's something to do with the sum of costs. So I highly suspect that this will all shake out if we just add these things judiciously. Omega is the cis of 2 pi on 9. 2 pi on 9. Omega squared is the cis of 4 pi on 9 by de Moivre's theorem. Omega cubed is the cis of 6 pi on 9, which we're going to write as 2 pi on 3 because that has an exact value. Omega to the 4th is the cis of, now it's 8 pi on 9, which I'm going to write, let's just write it like that, 8 pi on 9 for now. This is the cis of, now this I won't write like this. This is going to be the cis of 10 pi on 9, but by obvious understanding of the unit circle, the place 10 pi on 9 will give you the same cis if you use the negative 8 pi on 9. It's the same place on the unit circle. The cis of 12 pi on 9 is the cis of negative 2 pi on 3. The cis of 14 pi on 9 is the cis of negative 4 pi on 9. You always run out of space when you're doing these, but when you're doing them on, when you're doing them on the computer, you have the advantage of just being able to shrink things just slightly. Plus, so we've finished 14, so we've got up to 16. 16 pi on 9 is going to be the cis of negative 2 pi on 9. So that's going to be negative 1. Then we're going to judiciously add these. So if we add the cis of 2 pi on 9 plus the cis of negative 2 pi on 9, we're going to get 2 cos 2 pi on 9. We've demonstrated that in a number of cases already in this chapter. I don't think we need to reiterate that in this video. The cis of 4 pi on 9 plus the cis of negative 4 pi on 9 is going to be 2 cos 4 pi on 9. And the cis of 2 pi on 3, well, what is the cis of 2 pi on 3? It is negative a half. So it's going to be negative 2 times a half, if you will, those two put together. And then when we add those two, we're going to get 2 cos 8 pi on 9 equals minus 1. I think we can also see that these sum to 0, or cancel each other out on either side. We divide everything by 2, and then we get the cos of 2 pi on 9 plus the cos of 4 pi on 9 plus the cos of 8 pi on 9 is 0, but the cos of 8 pi on 9 is by the unit circle again, is the minus cos of pi on 9, and I'm pretty sure that was the thing we were trying to demonstrate. It's relatively, if you spend a little bit of time in these chapters, it's a relatively familiar idea. What does it look like in the unit circle? Well, I'll just do the first quadrant, because these angles, it's much better if I draw a circle here, isn't it? And then partially rub out, because of the magic of computers, partially rub out the bits I don't want, and then wholly rub out the bits I don't want. And then, there we go. So now we have a first quadrant, quite a large first quadrant. Yeah, so if this is re and this is im, and this is the origin. So what, you're going to have to split this into 1, 2, 3, and 4. So it's sort of going to be, so this is like going to be 3 pi on 9 here. This is going to be 4 pi on 9 here. This is going to be 1, 2. It's not very well done, is it? Pi on 9, 2 pi on 9, 3 pi on 9, 4 pi on 9. The key thing to recognize is that 4 pi on 9, what do we got up here is 4.5. Certainly, there's probably people who could sketch that much more beautifully than me. But what are we interested in? We're interested in this number here, the cos of pi on 9 in this place, is the sum of two other places. It's the sum of 4 pi on 9, the cos of 4 pi on 9, and the cos of 4 pi on 9 and 2 pi on 9 here. Yeah, so there's probably a geometric way of arguing that this distance here is the same as that distance there, as in that plus this equals the red one. Yeah. Anyway, that does seem quite a reasonable result. Obviously, we've proved it, but I just mean, like, it's sometimes nice to see if it looks like it would arithmetically also work out. We're asked to deduce. We're asked to deduce this result, and you might be tempted to try a product of roots. You've got z to the 9th minus 1 equals 0. The product of roots will give you 0. The product of roots is, the thing is, the product of roots is a series of cis's. It's cis 2 pi on 9, cis 4 pi on 9, etc. And those are fairly obviously, when you add the angles, or when they are going to end up being 0. That's not actually where you want to go with this. I feel like it has, well, obviously they've given you the first thing for a reason. So let's just say the left-hand side equals cos 2 pi on 4 plus cos 4 pi on, 2 pi on 9 plus cos 4 times the cos of 2 pi on 9 cos 4 pi on 9 from the first results. And then you've got to actually do a bit more work. No, actually, I probably won't do that now I think about it, because what I'm going to be most interested in here is the fact that the cos of 2 pi on 9 can be got from the cis of 2 pi on 9 plus the cis of negative 2 pi on 9. It doesn't equal that. Two of those equal that, yeah? Which you would write as, this is 2 pi on 9 for now. Well, that as omega plus 1 on omega. That middle term, the cos of 2 pi on 9 there is clearly omega plus 1 on omega. And then the same with, well, the same process with the cos of 4 pi on 9. Rather, it's a half of that. Yeah? And this here is also a half of omega squared plus 1 on omega squared, which leaves us with the cos 4... I should set this out better. Okay, let's just set it out better. So, i.e., the cos of 2 pi on 9 is omega plus 1 on omega. Similarly, the cos of 4 pi on 9 is going to be omega squared plus 1 on omega squared. But, I mean, we sort of did that. That was sort of what was going on up here when we were matching these ones. Up here when we were matching these things here. That's sort of what we were doing earlier, right? So I'm sort of doing the same work again. There's probably a smarter way to do this, but I'm just sort of going to go back to that. But the cos of 8 pi on 9, the cos of pi on 9, I'm going to relate to the negative cos of 8 pi on 9, which will give you the negative of omega to the 4th plus 1 on omega to the 4th. So our left-hand side becomes omega, the negative, in all of these cases, I've got it exactly wrong. We need a 2 and a 2 and a 2, to be clear, right? So, we're at negative a half of omega to the 4th plus 1 on omega to the 4th times a half of omega squared plus 1 on omega squared times a half of, that one was omega and omega, yeah? Omega plus 1 on omega. This one's omega, this one here is omega squared plus 1 on omega squared. And so then we're left with negative an eighth, and it seems like we're getting somewhere close to what we're after. Now, I'm going to choose to expand these two brackets here. So we'll leave omega to the 4th plus 1 on omega to the 4th for the moment, and this is going to be omega cubed plus omega plus omega plus omega plus 1 on omega plus 1 on omega cubed. And then I'm going to expand it fully to get omega to the 7th plus omega to the 5th plus omega cubed plus omega plus 1 on omega plus 1 on omega cubed plus 1 on omega to the 5th plus 1 on omega to the 7th. And now the thing that we need to not panic with here is these are not looking like they're easily going to sum. I mean, it's sort of like you've gone back to the cis's, and like the cis of 9 pi on 9 is the cis of 2 pi is 1. But if you just use the fact, note that omega to the 9th is 1, which we already knew, you're going to rewrite this as omega to the 7th plus omega to the 5th plus omega cubed plus omega plus, I'm going to multiply by omega to the 9th here and get omega to the 8th, and then omega to the 7th plus omega cubed plus omega squared, okay? And then what are we left with? Well, we're left with omega to the 1, omega squared, omega cubed, omega to, oopsie. Okay, well, that's a helpful thing to realize because I've just written the wrong thing. Okay, so this one is to the 4th, obviously, isn't it? When I multiply 1 on omega to the 5th times omega to the 9th, I get omega to the 4th. And when I multiply 1 on omega cubed times omega to the 9th, I get omega to the 6th. I've got to be careful here. So, yes, otherwise it's definitely not going to work. But now I've fixed that problem. We've got omega squared, omega cubed, omega to the 4th, omega to the 5th, omega to the 6th, omega to the 7th, omega to the 8th, which I think we have already proved is negative 1. And so we get equals negative an eighth times negative 1, which is an eighth, which is what we were after all along. Okay, I really feel like in part D, there's probably a cleverer way to do that. I don't know a cleverer way to do that. That's just the way that that I saw this time. I do feel like some of this work here, we're sort of redoing or undoing the work that we did earlier up here. So I feel like there's probably a smart way to do that. I would love for you to send me one. I'd love to be wrong. I'd love to be for you to be able to prove that there's a better way to do it. In the meantime, let's just keep at the maths.